In this video, we're going to look at three simple problems related to geometric sequences. For the first problem, we're given a geometric progression as first term 12 and second term 8. We want to find the common ratio r. So let's label what we have then. So we're given the first term u1, which is 12, and we're given the second term u2, which is equal to 8. If we want to find our common ratio, we can take the second term u2 and divide it by the first term u1, which in this case is 8 over 12, which simplifies to 2 over 3. And that's the end of problem 1, so very nice simple problem. Problem 2 says the first four terms of a geometric sequence are 10, 9, 8.1 and 7.29. We want to show that the common ratio of this sequence is 0.9. So it's a very similar process. Let's take two of our values. We can say that u1 is equal to 10 and u2 is equal to 9. If we want our common ratio, we do u2 divided by u1, which is 9 over 10, which is a decimal, is then 0.9. Alternatively, you can pick any pair of consecutive terms and do the second term divided by the first term out of the two. So for example, if we pick the third term, u3 is 8.1, u4 is equal to 7.29, we could say that r is equal to u4 over u3, which is 7.29, divided by 8.1, which in your calculator, it will tell you again is 0.9. So there's a few alternatives. You could do u3 divided by u2, so 8.1 divided by 9. Again, you'll get 0.9. Any of those would be correct, but the first one is probably the simplest. Just make sure you show this working of u2 over u1 if you're using that one. So we have our value for r. Part B then says to write down the nth term. Now because this is a geometric sequence, we have our general expression for the nth term, which is un is equal to a r to the n minus 1. Well, we have our r value, that is equal to 0.9, and for this sequence we also have our a value, which is the first term, and our first term is 10. So if we want the nth term then, we can say that un is equal to your a value, which is 10, times the r value, which is 0.9 to the power of n minus 1, because this is the general nth term, so we can't put a number in for n, so our power stays as n minus 1. And that's our solution then to problem 2. For the third problem, we're given the first four terms of a geometric sequence as 6, 2, 2 over 3 and 2 over 9. Write down the common ratio, and then part B, find the 10th term, giving your answer to three significant figures. So it's a similar idea again. With part A, we want to write down the common ratio. So for our sequence, we can say that u1 is equal to 6, u2 is equal to 2. So our common ratio r is equal to u2 over u1, which is 2 over 6, or when simplified, 1 over 3. Alternatively, for example, I could do 2 over 3 divided by 2, again that gets 1 over 3, or 2 over 9 divided by 2 over 3, which again will get you 1 over 3. So we have our r value. Part B says to find the 10th term. So we have our r value, which is 1 over 3. For our sequence, we also need to know our a value, which is the first term, and for this sequence that is 6. And we also need to know our n, well, we're looking for the 10th term, so n is 10. We can then use our nth term expression to find the 10th term, so we're looking at u10 is equal to our a value, which is 6, times our r value, which is 1 over 3, to the power of n minus 1. N is 10, 10 minus 1 is 9, which gets us, when you put that into your calculator, 2 over 6,561. That would be the exact value. However, this particular question says give your answer to 3 significant figures, so let's convert this into a decimal and round it. So it is approximately either 0.000305 if you want it as a decimal, or in standard form it is 3.05 times 10 to the minus 4. Both of these are to 3 significant figures. Both of those would get you the correct marks. Typically the standard form looks a bit nicer, but make sure you put what you've rounded your final answer to in brackets at the end, just to tidy off the question. And that's some 3 simple geometric sequence problems. In the future videos, we'll look at some more complicated problems related to geometric sequences.